Hmm. Hello. Hmm.
Hello.
Hmm. I think we completed exercise 1.1 na. Hello.
हाँ.
Look, exercise 1.1 first question. I expressed you know how to do the prime factorization. Divide the given number by prime number.
Prime numbers.
Okay. Then find the LCM and HCF of the following pairs of integer and verify that LCM into HCF equal to product of two number. You know how to find prime factorization. Then find the HCF and LCM. We have already covered in the exercise examples.
हाँ.
And question number 3, prime factorization. Number 3 number. Question number 4, given that HCF equal to this, find LCM. You can able to
LCM
find na?
again.
Hmm. LCM equal to multiplication of a given number
Multiplication of given numbers.
divided by 9 divided by
LCM into HCF
9.
हाँ ठीक है.
Check whether 6 power n can end with the digit 0 for any natural number n. Same as 4 raised to the power n. If we do the prime factorization, it will contain 2 into 3.
2 into
But
3.
any number that end with 0, that must be contain 2 and 5 as their product.
2 and 5.
Factor as their 2 and 5.
Hmm.
Then explain why are composite number, because I can convert it into product of a look, question number 6 I am doing. Question number 6. 7 into 11 into
11 into
13 plus
13 plus
13.
13.
The here 13 is common, no?
हाँ.
Took common 13. 7 into 11
11
plus
plus
1.
1. Hmm.
Then 13. 11 into 7 how much? 70.
7.
7 plus 1.
78.
13 into 78. Then I can prime factorize 78 so that it is a composite number, because I know by the theorem any number I can convert it into uh, product of a prime number. A composite
हाँ.
number is nothing but product of a prime number, na?
Hmm.
Same thing you have to do here. Okay. Then question number 6. There is a circular path. ये question 7 करथिलो ना?
ना.
पढ़िलो question number 7.
There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point?
Question बुझिबो ना बुझिबो ना? Hello.
हाँ.
Suppose
हाँ.
this is a circular path.
Hmm.
You and your friend starting from same line, same direction. You took 18 minutes to complete this circle. Your friend take 12 minutes to complete this circle.
Hmm.
But tell me, after how many time you both should meet again?
Oh.
Understand the question? After how many minutes will they meet again at the starting point? It is totally based on HCF and LCM question. HCF and LCM question. Okay? Then here you have to find what? LCM or HCF? Okay, tell me. This is a circular field. This is the marking point where you and Ravi start the rounding. You took
Hmm.
how many minutes? 18 minutes. Ravi took how many minutes? 12 minutes.
Well,
Okay, find the LCM, you will get the answer. After how many minutes you will reach. Okay?
okay.
It's totally based on HCF and LCM based question. This is not important for your exam. Okay. HCF LCM based ଗୋଟେ ଭିଡ଼ିଓ ଅଛି ସେ ୟୁଟ୍ୟୁବ୍ ଚ୍ୟାନେଲ୍ ମୋ ୟୁଟ୍ୟୁବ୍ ଚ୍ୟାନେଲ୍ ପଠେଇଦେବି ଦେଖିଦେବ. Okay? Means there are some words that represent you have to find HCF or LCM. Okay? There are some words on the question like same point, same time. Same time represent you have to find LCM. You have to find LCM. Okay. Then move to our concept. revisiting irrational number. Okay, so we are starting the chapter from number. We are starting the chapter from number.
Number.
Number is divided into two types: real number
Real number and
and
real
imaginary number. Imaginary
number.
number. Real number is again divided into two types: rational and
Well, rational.
irrational. Okay, we completed the rational part. Now starting the irrational part. Now starting the irrational part. Irrational number means any number that cannot be written, that
Like
cannot be written in form of a p by q.
P by Q
Q does not equal to
is
0.
not equal to 0.
PQ must be integer.
Not
PQ must be
integer.
integer. This is the, if any number that cannot be represented in form of p upon q, q does not equal to 0, pq must be integer. This is called the irrational number. Okay.
Uh,
For example of a irrational number. Example of a irrational number. Remember, any number under square root, if that number is not a perfect square, number is not a
Perfect square, then it is irrational.
irrational number. This is the one thing you have to identify. Otherwise, any number, any prime number inside square root is also a irrational number. Okay.
Hmm.
or or
Yes.
or or any number whose decimal expansion is non-terminating, non-recurring.
Non-terminating, non-repeating.
This is also the irrational number. Okay. Then look, these are the example of a irrational number. Are you looking? Apply the same rule. Look, under root over 2. 2 is a prime number. Na?
Huh.
3, 15. 15 is a
15.
not a perfect square. Yeah, I can write 15 as 3 into 5. Na? It is also prime number. Okay.
Huh.
Then look, this is a non-terminating, non-recurring. Okay. Look this theorem. This theorem is important. Read the theorem.
Let P be a prime number. If P divides by if P divides A2, then P
No,
divides
not a2. It is a square.
if P divides A square, then
Hmm.
P divides A,
Look,
where
now we have
A
to
is
focus on
prime
three things.
number.
Focus on three things. What do you mean by co-prime? Because we need this concept for upcoming classes. Co-prime. Number 2, theorem 1.2. Number 3, factor. Three things we need. Okay. So first things, co-prime. We already completed this concept now. Co-prime means pair of number. Pair of
Numbers.
numbers. Pair of numbers. It may not be prime number. It may be any number. It may be prime number. It may be composite number. But pair of number. Theta number of pair of numbers whose HSAP is 1. Whose HSAP is 1 is called co-prime. It's called co-prime. Look here, 5 and 11. Are these co-prime? Are these co-prime?
Huh.
Because 5 factor is 1 and 5. 11 factor is 1 and 11. Common factor is 1. So it is a co-prime. Same thing, 6 and 11. Are these co-prime?
No. Ha ha.
Yes. Look, 6 is a composite number. Here I am telling pair of number. I am not telling pair of a prime number. Pair of number means it may be any number. You understand what I mean by co-prime? Because we require this concept. Okay.
Hmm.
Then move to this. This is a square. This theorem is telling let p be a prime number if p divide 8 square. Suppose p equal to 3 plus p equal to 3. P divide a square. A equal to 6. A equal to 6. A square how much?
36.
36 divided by 36 is divisible by 3.
Yes.
Then 100% this p will divide a.
Hmm.
You understand the theorem?
Huh.
any number you took, 2. If 2 divided 4 square, then 2 divided 4 na?
हाँ.
This is the theorem meaning. Okay?
Hmm.
You can take any example. Then we have to do some simple revision. Remember. You understand these things na? If P is a prime number, if that P divide A square, then P 100%, P divides A square divided by P, then A also divided by P. This is the meaning of this theorem. Then move to some basic concept which we require. Look, tell me sum of a irrational number and a rational number will be what? Rational or irrational?
Um, Rational.
Sum of a rational and irrational.
Rational.
Irrational. What? Irrational. Remember this point. This is property. Sum of a rational number and irrational number is irrational number. Suppose the rational number is 2 and irrational number is root 3. Irrational number is root 3.
Root.
And you know the value of root 3 is how much?
Root 3.
1.732 dot dot. Okay?
Hmm.
This is the value. Look, root 2, the value is 1.414.
Hmm.
Root 3, 1.732.
7, 3.
Huh. Then 2 plus 1, 3. 3.732 dot dot. Look, it is a irrational number, na? Non-terminating, non-recurring. Sum of a rational and irrational number is 100% is irrational. 100% irrational. Same thing, the difference of the difference. Rational minus irrational. The answer will be irrational. The answer will be 100% rational. Same thing. 2 minus root 3. 2 minus root 3. 2 minus 1.732. The answer will be 1.732. It is irrational, na? Remember, irrational plus irrational, rational plus irrational, irrational. Rational minus irrational, irrational. Okay, then come to product. Then come to product. Rational into irrational. Answer will be irrational. Rational divided by irrational. Answer will be irrational. Okay, for product. For product, I am taking one example. Rational 4, irrational root 2. 4 into root 2 value 1.414 dot dot. Look, if you multiply, your answer will be coming dot dot, na? Because it is going on, you have to multiply with each term, na? Okay, so you understand basic things. Rational plus irrational, irrational. Rational minus irrational, irrational. Then a rational into irrational, irrational. And remember, this rational number should not be 0. Okay? The condition is 1, the rational number should not be 0. Because 0 into irrational number also 0. Okay? So this rational number except 0. Then same thing. Rational number. हाँ.
0 रैशनल और इरेशनल दोनों ही नहीं होता ना?
0 रेशनल नंबर है, 0/1 ना?
0/1 की वैल्यू 0. हाँ ठीक है.
हाँ. Okay. Then coming to next property, that is, tell me irrational plus irrational. Answer will be what? Tell me. Irrational plus irrational. Answer will be how much?
Irrational.
It's both rational and irrational. It's both rational and
root 2 plus root 2 हो गया तो 2.
wait. Root 2. Sorry, I'm taking one example. Root 2 plus root 2. You can put root 1.414 that plus 1.414.
4.
It will be 818.1. It is a rational number. Okay, I agree. Then I am taking one example. 3 plus root 2. 3 plus root 2 plus 3, 4 minus root 2. 4 minus root 2. 3 plus root 2 is a irrational number because a few seconds ago we learned na rational plus irrational 100% irrational. That means it is a irrational number. It is a irrational number. 4 minus root 2, it is also irrational number. Root 2 cancel. The answer will be 7. It is irrational, na? I am taking irrational plus irrational, but my answer will be rational. So it is irrational or irrational. That same thing. You look 3 plus root 2 minus 4 plus root 2. 4 plus root 2. 3 plus root 2 minus plus minus minus plus minus. Root 2 cancel. The 3 minus 4 minus 1. Minus 1 is a rational number, na? Okay. So irrational plus irrational, it may be rational, it may be irrational. Irrational minus irrational, same concept. Same. Irrational into irrational,
Irrational into irrational.
rational or irrational? Look, root 3 into root 2. Answer will be root 6. Answer will be
root 2 into root 2 हो जाएगा ठीक है समझ
root 6 because a into root b
2 हो जाएगा
root 2 into 2 into 2. You understand this concept? Okay. That means what we have completed? Co-prime, theorem 1.2, then some property. Okay, then tell me. Suppose 10 is a number, okay? 10 divisible by 2, 10 divisible by 2. That means, can I say, find that factor of a 10? 1, 2, 5, 10. If 10 divisible by 2, that means 2 is a factor of 10, na? These are the basic for going to prove root 2 is a prime number, root 2 is a irrational number, root 3 is a irrational number. These are the basic concept. Suppose I am writing 10 divided by 3. Is 10 divisible by 3? No, because the factor of a 10, 3 is not coming. You understand this concept? Then come to. Okay. Then. Then look. For proving any number, for proving any irrational number, how we prove the given number is a irrational number? We applying contradiction method. Contradiction method. Contradiction method means, suppose there is a man is standing. Okay, suppose there is a person who is standing. Okay. I am trying to know he is male or female. The person is male or a female. Okay. Suppose I am telling he is a female. She is a female. If I prove she is not a female, that means 100% he is male, na? Contradiction method means. Contradiction means, first we have to think for proving. Suppose I am proving root 2 is a irrational number. So think root 2 is a rational. Root 2 is a rational. If I prove root 2 is not rational, then 100% root 2 is irrational. So during proving, one thing you remember. Okay, how many property are there for proving a rational number? 4 property. How many?
4.
P upon Q form. P upon
Q
Q does not equal to 0. PQ must be integer. PQ must be. And the most important thing, PQ must be co-prime. Co-prime. What does it mean? Looks on the 4 concept. Looks on the co-prime. Look. I am telling one sentence you remember. Every rational number. In every rational number, So PQ are co-prime. PQ are a co-prime.
Oh,
For example, 3 upon 5, 3. 3 is a rational number. 3 upon 1. Look PQ. 3 and 1 co-prime. Yes, co-prime. 5 upon 11. 5 and 11 co-prime. Yes.
65 upon 66.
Look. I'm giving 6 upon 9. Is it a co-prime? That is also.
No.
I am writing the line. Look, in every rational number PQ are co-prime. But here, sir, 6 upon 9 is a co-prime number. No, sir, rational number. Na? But 6 and 9 are not co-prime. That means this is
Oh,
incorrect. No. Simplify form. I'm telling about only in every rational number. In every simplified rational number. In every simplified rational number PQ are a co-prime. Simplify means 6 and 9. I can simplify 2 upon 3. Then look, 2 and 3 are co-prime. Okay. So for proving any number, as irrational number, the main thing is we have to focus on co-prime concept. Okay. That means if I telling root 2 is a rational number, if I prove root 2 having root 2 rational means I can write in P upon Q form. And root 2 is a irrational number means I can write it in P upon Q form, na? So by the help of these things, I can able to prove root 2 is not a rational number. Okay? You understand the background concept? Now start the book.
yes.
Look, now you have to prove root 2 is a irrational number. Root 2 is a irrational number.
Let us assume root 2 is rational. So,
Everything, whatever we complete, here we have applied. Okay, look. We have to prove root 2 is irrational. Root 2 is
irrational.
Root 2 is irrational. Okay, contradiction method. We have to apply contradiction method. Let. What you have to write? I will send you the video. Listen. What you have to write in exam? I will send you the video. From video, you have to write down the note. Okay? Unnecessary. Don't waste the time during the class. Root 2 is irrational. We have to prove this. We are starting proof. Let root 2 is a rational number. We have to apply contradiction method. So we have to write let root 2 be a rational number. Root 2 be a rational number. Okay. If root 2 is a rational number, what does it mean? I can write root 2 as P upon Q. Let root 2 be a rational number. What does it mean? I can write root 2 equal to P upon Q.
P upon Q form.
Where
Q not equal to 0.
PQ are co-prime. PQ are
Q not equal to 0.
co-prime. What does meaning of PQ are co-prime? Wait. What does meaning of a PQ are co-prime? HSE of PQ is 1.
Of PQ is 1.
That's enough. It's only enough to prove. Okay. Then this is the first step. Then squaring both sides. Then the second step is squaring both sides.
तो root 2 तो 2 हो जाएगा ना?
हाँ. Root 2 square upon P upon Q square. It will be 2 equal to P square upon Q square. 2. Okay?
Equal to P square upon Q
हाँ.
square.
Then took this Q square into left hand side. So it will be 2Q square equal to P square. Okay? Then Q square equal to P square upon 2. P square upon 2. You understand till this? does it means? If p square divisible by 2, that means p also divisible by 2. Theorem 1.2. Any prime number that divide p, that divide a square, that means that prime number divide a. Okay. And remember my concept. When a number is divisible by any number, that number should be the factor of the given number. That means 2 is a factor of a p. Can I write here 2 is a factor of a p? You understand till this? Give this as equation 1. Give this as equation 1. Okay. What I am trying to do here, look. I am trying to do here P and Q having HCF greater than 1, means except 1. Okay, what I am doing here, I am trying to do here, look, coprime means it should have HCF as 1, na? But here I am trying to find HCF of P and Q except 1, means there is another number. Okay, that's why I am doing these many things. In mind, you have to keep what I am doing here. Then look, you are proving root 2, na? You are proving root 2 be a rational number. Okay, I am taking p value as 2k. P value as 2k. You ask me the question, sir, why are you taking 2? Because you look, 6. Suppose 6 is a number. Okay, if I am telling 6 is divisible by 2, that means can I write 6 as 3 into 2? Any number in the world that divisible by 2, any number in the world, 10. If it is divisible by 2, then can I write 5 into 2? Same thing apply here. I am telling p is divisible by 2. That means along with 2, any integer is there? Same thing you apply. That means here the k is any integer. K is any integer. And 2 into 1, 2 into 2, 2 into 3, all are divisible by 3, na? All are divisible by 2, na? Same thing. P equal to 2 into 1. It is also divisible by p. P is equal to 2 into 2. So instead of writing every number, I am taking k. Then put the value of p. Put the value of p in equation 1. In equation 1. So 2q square equal to p square. This is the equation 1, na? Okay. 2q square equal to p square how much? 2k, na? Then it will be how much?
2q square equal to 4k square.
Took this 4 into left hand side.
Q square.
2 or 4 cancel. Q square divided by 2 equal to k square. Look, if q square divided by 2, then q also divided by 2. Then can I conclude 2 is also a factor of q?
अब 2 factor आ गया तो ये coprime.
So they are not coprime. They are not coprime. So at last you have to write 2 as the, thus that indicates 2 is the common 2 is the common factor. 2 is the common factor of both p and q, p and q. So p and q are not coprime. So it is contradicted. Root 2 is irrational. Okay. You understand the concept? For root 3, same concept. Only you have to take p equal to 3k. P equal to 3k. Root 5, same. P equal to 5k. Or p equal to 5k means what? P is a number divisible by 5. That means p, I can write p equal to 5 into k, where k is an integer, na? You understand? You have to remember background concept. What is going on the background? If you don't understand the background concept, you don't understand what is going on. Same thing I am doing for root 3. Look once and guide me. Let root 3 be a rational number. Root 3 be a rational number. If root 3 be a rational number, I can write root 3 equal to p upon q. Where don't remember those many property, only remember pq must be co-prime. Pq must be co-prime. That means HCF of a p comma q should be 1, na? And then squaring both sides. Squaring both sides. It become 3 p square minus q, p square upon q square. So I can write 3q square equal to p square. This is equation 1. Q square equal to p square divided by 3. P square divided by 3. If p square divided by 3, p divided by 3 also, by applying theorem number 1.2. By applying theorem 1.2. Then that means 3 is the factor of a p, na? Okay, are you remembering the step? Then p equal to 3k. P equal to 3k. Where k is an integer. Where k is an integer. So p equal to 3k. Putting this value on equation 1. Putting this value in equation 1. So it will be 3q square equal to 3k square equal to 3k square. So 3q square equal to 9k square equal to 9k square. So coming 9 to this side. 3 upon 9 q square equal to k square. 3 simplify, q square upon 3 equal to k square. That means q square divided by 3. Q is 3 is a prime number, so q also divided by 3. आ गया answer. 3 is a factor of p. 3 is a factor of a q. So that contradictory. You understand the concept? Okay. Then you can able to do root 5, root 7. Okay. If this type of question is coming, you can able to do na.
3q square equal to 9k square के आगे क्या था?
3q square equal to 9k square. And then 3q square upon 9 equal to k square. Simplify. It will be q square upon 3 equal to k square. Look, root 3, root 2. Okay. Look. This is 5 example. The question is 5 minus root 3. Look, if root under prime number is directly coming, you can apply the previous method. Okay? Like root 2, root 2, root 5, root 7, root 11. These are the prime number, na? You can easily do. But the question is coming like this. 5 minus root 3. 5 minus root 3. Okay? You have to prove it is a irrational. It is a irrational number. It is an irrational.
5 minus root 3 को हम PQ ले लेंगे.
Okay. Let assume 5 minus root 3 is a irrational. Is a rational. Is a
p plus 5 upon q हो जाएगा.
तो 5 minus root 3 equal to p upon q. Okay. Then took this root 2 into right hand side. 5 equal to p upon q plus root 3. Okay. Remember. Look this side. 5 is rational or irrational?
Rational.
Rational number. Okay. P upon Q, rational.
Hmm. Hmm.
Root 3,
Irrational.
remember the sum of a irrational plus
Irrational
rational.
plus
Rational plus irrational.
is irrational.
Irrational na?
Irrational.
So that means think. This side a rational number. This side irrational number. Is it possible? A rational number equal to irrational number.
No.
Is it possible? So that contradict. That
No.
contract. That contradict. 5 minus root 3 is a rational number. You understand? And the same thing. Look, if 5 plus root 3 is also coming. If 5 minus any number. If plus minus, look, a number plus minus any number, any irrational number. Irrational number, look, irrational number plus minus symbol, irrational number. Okay, then prove by this way.
हाँ.
Prove by, suppose 5 minus root root 7. How to prove? Plus. Same. P upon Q, 5
P
equal to
upon
P
Q.
upon
5
Q minus root
equal
7.
to P upon
And you know
root
irrational,
7
this side irrational,
minus root 7
this side irrational.
and this side irrational.
How they say, how they will same. Okay?
They are not same.
It's such a easy method. Then what I am telling, rational number plus minus irrational.
Hmm.
Then sir, what about rational number into irrational number? If suppose this is coming, look, 3 root 2, 3,
Rational into
3 root 2, you have to prove it is a irrational. It is a irrational.
irrational.
Same thing. Assume it is a, assume it is a
Rational number.
rational number. Then took this 3 into right hand side.
P equal to 3. P upon 3. हाँ. 3P upon Q root equal to.
Okay. Root 2 equal to P upon 3Q.
हाँ.
Tell me, this side is a rational, irrational number. This side it is a rational number. Then how this same? How this will be same?
Not same.
Okay.
Okay.
We completed plus minus. We completed. What is such a this much only? The main concept is look. We completed directly by prime number under root.
Hmm.
Root 2,
Hmm.
root 3, root 5, root 7, root 11. You can able to do. Then plus minus. You understand?
Hmm.
Means number plus minus a rational number. Such a easy thing.
Hmm.
Multiplication also we did.
Hmm.
But the one thing is if two numbers are irrational. How to do this? Look, root 5 you know how to do?
3 plus 2 हो जाएगा 5. 5 root 5 हो जाएगा वो.
Look. 3 plus 2
नहीं.
root 5 equal
3
to
plus 2
P
root
upon Q.
5. 2 root 5 उधर चले प्लस 3 उधर चले जाएगा. 2 root 5 इधर रह जाएगा. P plus upon
Otherwise you can take remain 3 on left hand side. Took this into right hand side. And this is rational, this is irrational. How it will be same? Okay? You can able to do now all these questions?
हाँ.
Okay. Write down one homework, that is root 2 plus root 5. Here both are under root. How you prove this is a irrational?
Hmm.
This is homework for you. With this we completed this chapter. Okay?
Okay. Okay.
That is all these questions.